Um, okay, let me share the screen. Okay, should be visible now. Is it okay?
Yeah, looks good.
Perfect. So today's workshop is about building smart contracts for Soroban with the assembly script Soroban SDK. And so the agenda is I'm going to present a basic intro into the SDK and into the concept of the environment for the Soroban smart contract so that we can see why we need to use the or where the assembly script Soroban SDK helps to implement the contracts. And then we are going to build, deploy, and invoke some smart contracts live. So, and we go throughout examples that are also available in an examples repository. Both of them are open source, so the SDK and the examples repository is open source. And during this examples session, um, there can also be questions and answers. So in the first two, I will not look into the comments, but here when we are here into learning from examples, I will also look into the comments, and then we can also talk about the questions. Okay, so let's start with the basic info. So like here is the a picture of the environment. I hope you can see it. And there's a host environment which has a lot of functionality. And within this host environment, there's a guest WebAssembly virtual machine where the smart contract invocation is running. So when we deploy a smart contract, the host environment will have the WebAssembly bytecode. And when it invokes the smart contract, it invokes it within this guest virtual machine. So, and in this guest virtual machine, it is a low-level WebAssembly virtual machine. It has no garbage collector, no memory allocator, no I/O facilities for storing, no standard data structures like lists, arrays, maps, and no concept of objects and types besides this basic machine types like 32 or 64-bit integers. So it's very basic stuff that can be used, but the host environment offers the rich functionality of objects, for example, that cover data structures like vectors, maps, binary blobs, addresses, fixed integers, and also host functions that act on these host objects, for example, to be able to create these vectors, modify them, manipulate them, and also host functions that are that manage storage of data, events, calling other contracts, authentication, and so on. So in this, the smart contract can invoke those functions by using the environment interface, which is implemented by the host environment. And this environment interface has like 130 functions or something like this. And the communication between the smart contract and the host environment is defined by this interface. So the guest can communicate with the host by using this environment function and can refer to host objects that are created within the host environment, like for example, vectors, maps, and so on, by integer valued handles. So this is to explain this. So the communication of values that can be sent to these functions, or when the host environment invokes the smart contract, are always 32 or 64-bit integers. So, and these values, we can see here, these values and types that are sent back and forth, they encode the real values. So they are like bit 64-bit integers carrying a bit package disjoint of several cases. It looks like this. So, for example, if here is the in the last bit there's a tag representing, for example, that this is a 32-bit integer or a status or something else. They can also be constructed like this. And there are many different types of these tags. So, for example, tag with a value of 10 is a small unsigned integer with 128 bits. It's an object or a small value that can be used within this 64-bit integer. So the communication back and forth between those are always integers, and these integers can represent different things, like, for example, different kind of values or handles to objects that are within the host environment. Okay, so and how can the AssemblyScript SDK help to implement the smart contracts? So it offers access to these host functions like that are defined here, so that the developer can directly use them. So they are directly like exposed here, or also there are wrapped versions of them that make the usage even more easier. And the next point, which is very important, is that it supports value conversions. So this means that these types, these values are converted back and forth, so decoded and encoded, so that they can be used for the communication. So the developer is using normal integers, and the AssemblyScript SDK can convert it to a value that can be understood by the host environment. It also offers different SDK types which wrap those two things. Like, for example, we can use directly vectors or maps with the SDK as an SDK type that manages the corresponding handle, object handle, and accesses the needed host functions. Also, the AssemblyScript Sorbonne SDK helps to construct the WebAssembly bytecode, which needs to contain different custom sections so that it can be deployed and used by the host environment. For example, if a smart contract defines different methods or functions, then they need to be defined within these custom sections so that the host environment knows how to invoke them. And of course, it builds the WebAssembly bytecode from the TypeScript code or AssemblyScript code that the developer is implementing. So this is a short basic introduction, and now let's have a look to the SDK. So the SDK is here. It's an open source repository. Everybody can view the source code and contribute to it. So I'm just going to post it here. Okay. So, and now I would just like to create a new project so we can from scratch, so we can see how it works. Like, I'm going to take the info from here. So let's just do it like that. So we go here into this new, which is called hello. And now we initialize the project. So yes, here we can add all kind of, it's not so important now, information. Now we need to install AssemblyScript into this project and initialize the AssemblyScript project. So this is what it will create. Yes. Okay, now we have our assembly script project. We can open it and let's have a look. So it is created, and now next what we want to do is to install the assembly script Soroban SDK. Can do this here. So now the SDK is also part of the of our project, and there is a file which will contain our smart contract, which is called index TypeScript. Here is some example code. What we will do now is to copy the code from here. This is the code for Hello World contract example, and as we can see here, it uses different things from the Soroban SDK, different types of value, which are, these are always integer 64. It is just an alias so that it's better to, it is easier to read. So, and what we do here is we expose a function which is called hello, which expects an argument of type small symbol value, and returns a vector object. So this vector object is also an integer 64 value containing a handle to the vector object within the host environment. So now here we define a new vector, which is an SDK type from here. So it handles, when we define this new vector, it handles everything with the host environment, so that a host object is a new host object is created and is ready to be used. So we cannot see it from here. This happens in the SDK. Now we can use this SDK type to put corresponding data into it. So we transform this string into a host small string host object value or host value, and put it in the front of the vector. Then I don't know if you can see it. Hope it's better. So, and now then we push back the into the back of the vector. We put the value that we received by argument. So this is the classic hello world, also from Rust. From the Rust examples, the classic example, it is not the easiest one. There is another one which is simpler. I will show you that also, but here we can see a lot of things. So, and then we return the host object of this vector that we created from the SDK type. So now this is the implementation of the contract. And but as we discussed before, the contract must also expose in the custom sections this function, so that the host environment knows how to invoke the contract. And for this, we need to create a new file which is called contract.json. And here we can define the functions that are exposed by by our contract. All these values are described in the repository, in the documentation. And finally, we have to define how AssemblyScript needs to compile this source code to the WebAssembly binary. And this is very easy. We just have to extend this file asconfig, which defines how to build it. We just say that it extends the one provided by the AssemblyScript Soroban SDK. So the Soroban SDK takes care of this and knows to read the contract JSON file so that it can expose the custom functions, the custom sections. So that's it. And now let's build our contract. We build it for release. So now it uses the AssemblyScript Soroban SDK to build this contract and to also add the corresponding custom sections. And now we can use the Soroban CLI to see what happened. So first, it created a new file in the build folder. So we see here we have the release WebAssembly code file, and it also generated a WAT file, which is the readable text representation of this file. WAS file. We can also see it here. Like this is the readable one. The other one is bytecode, so we cannot read it. So, but we need this file, the WebAssembly bytecode file, and we can now, for example, inspect it. Sorry. So we can see here, okay, it was built by the AssemblyScript SDK version 1.0. It exposes the function hello, and the input is this argument 2 of type symbol, and the output is a vector with symbols. So now we can, for example, deploy that contract. So we can deploy to, let's say, to testnet. Takes a bit. Okay, so now we received from the testnet, we received the contract ID, which is the ID of this contract, and now we can invoke it. Like we can invoke it, like for example, like here, but we don't need all this stuff. We can also just write it. Contract invoke. ID, we have this ID. And we want to invoke the function hello with the parameter 2, and the value of the argument is friend. Okay, let's hope I typed everything correct. So now you see it has invoked our function, and it returned a vector of 2 symbols, which one is hello and the other one is friend. Okay, so as you can see, it is very easy if you to get into it. If you just copy from here, and then it explains everything, what it can do, also how these value conversions work, and how the SDK types work, what kind of SDK types are available. Like for example, we use the vector, errors, everything, also the contract spec generation and so on. So, and next I would like to
Hey, one second
go
before you
to
move
the
on.
next-
Can you explain what quote unquote Alice is in that last code you just typed? You just have some questions in the chat.
Sure. So, yes, okay, no problem. So what is Alice is it's a generated identity within the Soroban CLI. So if you go here to the Soroban CLI, where is it? Documentation. So you can, let me post this here. So like there is a documentation, and here you can see all the commands that you can use, and you can, for example, say now I want to generate for example, Soroban identity generate a new one, and I can generate this identity like for the network testnet, which is called, I don't know, Hugo. And what it does, it generates this Hugo identity, which can be used as an alias here. And if you look, for example, Soroban keys, address, Hugo, it shows me the public key of it, and this we can see, for example, in the Soroban in the Stellar Laboratory, we can see this account has been created. It should be, but not on public. So because it was a like this has been created and is just a new identity, and a Soroban CLI knows its key, its secret key. So for example, I think it's Soroban keys, and then let's see here. Where was it? Keys address. It shows the public key, and there's also one which shows the secret key. Let's have a look here. So you see, these are all the commands that you can use with the Soroban CLI. Keys show, I think it is. So the private key. So like keys show Google. So what it does, it uses this secret key to sign the transaction that it generates in the CLI to invoke the smart contract. Do you have more questions to this, or is it clear? Like,
I think that was the only one, unless, yeah, I think you're good.
okay, and the same here is with this network testnet. You can configure here networks like described in the general Soroban documentation. Like in the Soroban docs, everything here is described from in the official Soroban docs. For example, here in getting started, it is just described how you can configure an alias for a network. So here you can see, for example, how I created the testnet alias. So, and then I just can use it within the CLI. So this has nothing to do with the assembly script Soroban SDK. It's using the CLI to invoke the smart contract. Okay, so next I would like to go to the examples directory. So we have a lot of examples here that we can use to learn. So let's see where examples. So there's an extra repository for this. They're also available here, but let's go to this example repository. So this is the repository for the examples. And so we have here the easiest one is the add. This is the simplest to understand. So let's clone this repository first. So we go here. So now we have this repository here cloned. So let's go into this RS Soroban examples. So we have here different examples. So let's start with the first one, which is the easiest one. In all these examples, there's a README file, which explains everything about the contract. So here, of course, we have to install the Soroban CLI so that we can invoke it later. Now what we have to do is to go to to the corresponding directory. We install the dependencies, which include the AssemblyScript SDK. It installs everything, and now we can build it. So now everything is built, and we can see it here. It already has this. So now let's have a look to it, to the contract. So as described before, the contract is here. It's very simple. And also we have here the definition of the function. Like it offers one function which is called add, and it has two arguments of type integer 32, and it returns integer 32. Also here is the metadata for the description of what it is about. So let's have a look to the contract. So now, as you know from before, when called by the host environment, there's always integer 64 values that encode the real values. So like this could be also like is the same. So it's just an alias from the SDK. So we can it's better for reading. And what it says that it accepts a parameter, an argument of integer 64 host value, and another one of integer 34 host value, and it returns to the host again this value. So now first we need to decode them so we can work with them. So what it does, it uses the SDK to decode this integer 32 values which are encoded within this host objects into normal integer 32 values that we can use here. Then we build a sum of them, and then we encode them back into a host value, and then we return the host value. So let's have a look. Like we can also deploy this one. So this deploys it now to the test network, and then Soroban contract deploy. Sorry for this. Sometimes I forget. So this is functionality of the Soroban CLI, which is very important. So now I deployed the contract to the testnet, and we received this contract ID. Now we can invoke. So the ID is this contract, and we want to invoke the function add with the parameter A is, let's say, 3, and B is 5. So what it will do, it will receive the host values, it will convert them to normal integers, to primitives, will sum them up, and then return should be 8. Oh, you see, it invoked it on the testnet. So the same thing we can also do like on the mainnet. It's the same. So it makes no difference. So let's deploy. I have another entity here for the mainnet. And we can deploy it here. So just when I created the mainnet alias, I used an RPC URL from QuickNode. So they have free RPC URLs that you can use. And this Soneso account is an account from me where I have some movements on it. So let's have a look. So we have here some, it's on the public net. So we have here some, I don't know, 9 lumens. So now we deployed it to the mainnet. We have this contract ID, and now we can invoke it. This one, let's do the same, like here. So now it did it on the mainnet. So we can also look like what is, have a look to this transaction. So it's this address. Let's go to the Stellar Expert and look what happened here. So we have here the transaction. You see on the mainnet, it invoked a contract, our contract, this one that we have here. I don't know if you can see it, with the arguments 3 and 5, and this was the price for invoking it. And then it returned 8. So this is the simplest of all the example contracts. We can also like see what because we defined here in this contract, we defined the parameters. We can also like see what is inside. Even better, I cannot resist doing this. So let's go to this one. So this. Using ChatGPT to do this. So we have here SDK version 1.0. The name is add. We have this contract functions with those inputs and with that output. Exactly as defined here. And implemented here in the. Okay, so next. So if you have any questions? No. Okay, then let's go to the next one. So here. So the next one in the list is Hello World. This one we had already. So let's go to the increment example, which demonstrates how to write a simple contract that stores data. So also here it's described how to run that. So we go to now we have to install everything. So and then we can just build it. It's as easy as that. And let's have a look to the contract. So now we have it's already built. So we have this vast file here. So now let's go and have a look to the code. Increment example. It has exactly the same structure as always. Make it bigger. Yes. So we have here the contract JSON defining that it offers one function, which is called increment, and it returns an unsigned integer of 32. And let's have a look to the implementation. So we have here different examples, but it's not so important now. For now, let's just look to the first one. So as defined, we have one function which is called increment. And now we define here a key where to store the data. And also we have our counter, which is 0. Then we look into the ledger by using the SDK. So this will communicate with the host environment. And we can check if there is already data for this key for the storage type persistent. So there are different storage types. You can read about them in the Soroban documentation. So and then if there is something stored, then we load this object. And because we know we put into this storage, we put unsigned integers of type 32. We know that it is a 30, unsigned 32. So we have to convert this this host object to a primitive that is like this one. And now we can increment it, and then we put it back into the storage with the same key. And we have to put a host object because the communication with the host can only be with this value types, and for the storage type persistent. So and then we return with what is stored here in the ledger. That's it. So this is not, we can make it more effective and we can optimize this, but it is just for understanding, for better understanding what happens here. So for example, we don't need to load it here again. We could just return this. So, but this is a demo to see what happens. Now we implemented this contract, and now we can deploy it. Time is running, I know.
It's okay if you go a little over. Don't worry about it.
Excuse me?
If you go a little over time, it's okay.
Okay, so okay, and then okay, let's deploy that. So we received the contract ID. Now we can invoke it. All this is described here in the example, so you can use it from here. So everything what I do here is all, it's described in the repository. So we have the ID, this one, and we want to call the function increment. Okay. One. First one, increment again. So, and so on. So now, as we can see here, it uses in the first run it had no data, so it just incremented the counter to 1. It put it here the value of 1, and in the next run it had some value. It was 1. It incremented it, put the new value into the ledger, and returned the storage data. So this is how we can use the SDK's functions, like ledger has data or get data, or all this is described here in this part of the assembly script Soroban SDK, to easily access the storage from our source code. Another example which is maybe interesting is the out example, because it uses the authentication. So here we have, it's the same example like the increment example, but now we store the data depending on a user. So if, we pass an address object, so this is the address of our user, and the counter value, also how much to increment. And now what is interesting here is that we require authentication for this user. So each user can only increment his own counter. So there's a lot of comments here, because it explains that require out is the same like require out for arguments, which can also be alternatively used for instead of this SDK function. So and now we have the counter, and we store into the ledger for this user and storage type persistent. So we check if there is anything stored there. If yes, we take the counter and increment it, and then we save it again for this user. So the key is the user address. And then we return a map which contains the address of the user and the updated counter value. So let's have a look to the specification. So here you see we have a function which is called out, which increments, and it has two arguments, like the user, which needs an address, and the value which should be incremented, or which should be incremented to the current counter value, and it returns a map host object with the address, which represents the user, and the new value. Okay, let's go to this. So again, we need to do all, so to install it. Let's go here, and like it's always the same. So now we have the release, the binary. Now we can deploy it. So now we have this contract ID. Let's have a look what is described here. Now it says that you can generate different identities. So we have account 1 and account 2. Let's have a look. So we generate those. To be able to use them to invoke the smart contract with different identities, so with different users. Okay, so we have these two new users, and next, So like as described here. Next, let's invoke. I'm just going to copy this and update it like we have the data here. Like the contract ID is this. And the user has to match with the first one. Okay. So, and we will increment the value, which is now 0 because it was not called before, with the value of 3. So it goes to the Soroban testnet. Okay. So here it calls the function out of our contract with this user, and it returns a map showing that this user's counter is now 3. If we repeat this, it will be 6 because it will increment it with a 3. So now we see it is 6. So it stores the data depending on the user, and the user needs to authenticate himself to pass. So and therefore we use the user's identity, which we defined here, to sign the transaction. We can do now the same with the other user. So it was account 2 and this ID. And now we make the value, for example, 5. And now we can see that it stored the data in the ledger for this user with a value of 5. If we repeat that, or we can also change the value here to make it so it should be 7 now. And it is signed by this other user. So every user can only update his own data. So there are a lot of examples like this. So these are the simple examples. I would like to go throughout one more example, which is called contract event.
Two questions real fast about the last one?
Yes.
Can you
Yes,
explain the
yes.
difference between require auth and
Yes.
require auth for? Yeah.
Yes, of course. Let's go to the source code. So if you see this out, where is it here? Okay, so if you look into this, so require out already uses the arguments which are given by the function, and here you can put arguments where that need to be authenticated. There are two different. These are two different host functions that are involved here that can be. So you see here it goes to two different host functions, this and this. And here in this, here we have all the host functions, the mapping of all the host functions that we can execute. So let's go back and see how to find out what the difference is. So you see here, it explains with the provided arguments, and also this is when we provide some arguments, and this one checks with the arguments of the invocation. So in our case, they like in this example, they are the same, but they can be different. So it's and therefore here it would be the same if we just use user and value as an argument. But in some other use cases, maybe we need only a part of them or other things. These host functions, the definition of these host functions can be found here, and in the Soroban environment. So there are many of them, like 138 or something, with all the host functions that can be called.
Oh, sorry, I missed that. Silence has another question from earlier. He asked about generating bindings for a contract built with assembly script. Also, I assume the same as the normal Rust contract. Is that?
So you can use the Soroban CLI to generate like the bindings, because these bindings are generating based on the contract spec. So like Soroban contract inspect. Sorry. So the bindings are parsed from the binary code, which contains these custom sections like environment metadata, contract metadata, and contract spec. And based on this contract spec, it generates the bindings. We can have a look to this. I think it is CLI doc, Soroban, let's have a Soroban contract. Where is it? Inspect. I don't know, bindings.
It generates the bindings off the WASM, not the
This
source.
one.
That's following.
Soroban contract binding, JSON.
No problem.
Awesome. That's it. See, it generates the bindings from this, from the contract. Is it like answered?
Is that good? Silence? Yep, you got it.
Perfect. So the last one, so there are a lot of, there's many things to see here in the examples. So like, for example, let's have a look to all this. So here we have increment example, which demonstrates storage. We have the events example, which we can look into it. This is the last one, we are looking into it. So then we have the errors, logging, authentication. We already looked into it. We can see how we can call other contracts, how to deploy a contract, how to upgrade a contract so that it can be changed. So how testing would work. Token example, which demonstrates how to write a token contract that implements the official Stellar token interface. Atomic swap, so it gets more and more complex, and is all explained there. So because we don't have so much time, let's go to the events example. So because this is an interesting one, we can see that some events have been published. So let's go again to the events. And now it's always the same. Install. And then build. Okay. Now we can deploy it. Let's deploy this one to mainnet. Soroban contract deploy. Okay, in the meantime, let's look into the contract. So it's contract events, and it uses the assembly script. So it's again the increment example, but when the counter was incremented, it creates a vector from the SDK with the topics, which contains the key counter and the small symbol string increment, and then it uses the SDK to publish the event. So, and then it returns the counter. So super easy to use. And now we have deployed this contract. Let's have a look to how it is, what it has a function which is called increment. We just have to call that. We can see it here also. So let's do that. and we need the function increment. So now it should publish an event. So yes, it published an event. Here it's a little bit difficult to read in this Soroban CLI, but we can see here that it published a vector with topics counter, increment, and the data is run. We can also look here and ask GPT. Copy it here. This was the contract. I have a typo, but I guess it will check it. So we have counter, increment, value 1. So this was the event which has been published. Okay, that's it. So if you want to learn more about the AssemblyScript Soroban SDK and how to use it, I would recommend to go throughout these examples. And to create contracts, you can use AssemblyScript, which is a TypeScript and dialect of TypeScript.
Thank you
And
so
you can
much,
use the
Sinesso.
functionality
Sorry, go
from
ahead.
Okay.
Thank you guys.
Do you have
for
any?
coming.
Yes, so it generates the. I think this is old. The question is old. Yes, we already
Oh yeah, we
talked
asked
about
most of
it.
them, I think. Yeah. Pretty
Super,
sure.
thank you.
Yeah. Thank you guys for coming. And if you guys want to see the full video of this, it's going to be in the video content channel under community, probably a couple hours from now. And I will hopefully, they asked if actually I could get a link, Sinesso, from you to the slideshow you showed at the beginning. Is that possible?
To this agenda, to this
Yes,
test.
that's the one.
So I
One
just
with the
have it
picture.
here on my computer, but I can send it to you if
Okay,
you
perfect.
would like.
Yeah, I'll link the slideshow with the video later, guys.
Thank you.
Oh, wait, is there one more question? Oh, yeah. Thanks, guys. Bye.
Bye.